We've seen several times that energy can be transferred from one form to another, but it's not always transferred into the form we intend because most devices aren't 100% efficient. In today's video, we're going to look at what efficiency is and how to calculate it in terms of both energy and power. Let's begin by considering a lamp whose input energy is electrical energy, while its output is split between light energy and heat energy. Since the purpose of a lamp is to provide light, we consider light energy as the useful energy output, whereas heat energy is classed as waste energy or non-useful output. The efficiency of such a device is simply the proportion of the input energy that is actually transferred into useful energy output, in this case, light energy. For exams, you'll need to calculate efficiency either as a decimal or a percentage using the formula. Efficiency equals useful energy output divided by total energy input, or if using power, efficiency equals useful power output divided by total power input. To see this in practice, imagine we have two lamps, each supplied with 300 joules of energy. The first lamp has an old incandescent bulb that converts 4 to 5 joules into light, while the second uses a modern LED bulb that converts 225 joules into light. To find how many times more efficient the LED is, we first calculate efficiency. For the incandescent bulb, we divide 4 to 5 by 300, giving 0.15. For the LED, we divide 225 by 300 to get 0.75. Then we divide 0.75 by 0.15 to find the LED lamp is 5 times more efficient. If we want percentages, we just multiply the decimal values by 100, giving us 15% and 75%, and 75 divided by 15 still gives 5. A common mistake when calculating efficiency is reversing the division, which would give you a value greater than 1 or greater than 100%. In our example, you'd get 1.33 or 133%, which is impossible because it suggests more energy output than input, violating the conservation of energy principle, which states that energy can be transferred but not created or destroyed. Let's now try an example using power. Suppose a microwave is 70% efficient and has a total power input of 800 watts. To calculate useful power output, we first convert efficiency into a decimal by dividing 70 by 100, giving 0.7. Then we multiply 0.7 by 800 to get a useful power output of 560 watts. No device is 100% efficient because all devices produce some form of waste energy, usually as heat. An exception is when the purpose of a device is to produce heat, like electric heaters, in which case thermal energy is considered useful rather than waste. That's it for today, so if you enjoyed it, let us know down below and we'll see you next time.